Good morning, students. Now we are going to the new chapter, is the probability distribution. We already see in 11th and 10th standard probability sums. Now we see some elaborate problems. In first probability distribution, we introduce one concept, the random variable. We already know the concept of a random variable. Now we introduce a random variable. What is meant by a random variable? For example, I say one coin is tossed. Suppose we assume the head is a success. There is a chance. Yes, a probability means the possibilities. We tossed a single coin. The faces, it may be head or tail. We assume, suppose tail is the success or head is a success. It's your choice. Suppose I assume tail is a success. We tossed only once, one time. There is a chances. So this chances is nothing but a random variable. This happen may be possible or not possible. Not possible means all the time tail is not. One or two times head is also a possible. So this concept is called a random variable. Now in 12th standard, we introduce two types of random variable. One is a discrete random variable, and another one is a continuous random variable. Just two types of this random variable. In all the sums, the number of values of the random variables are very important. The first one, discrete means countable values of the random variable, and continuous means it can take so many values in between this one interval. I give an example. A discrete random variable, all the random variables are countable. Suppose we tossed 4 coins at a time. 4 coins at a time. Suppose we assume head is a success. So how many chances of head will come? I say in all 4 coins 0, 1, 2, 3, 4. What is meant by 0, sir? We tossed 4 coins at a time. The head is not a come. There is a chance. So random variable values is 0. In out of 4 coins, any one coin there will be head. There is a chance. So random variable value is 1. 2 means out of 4 coins, there will be 2 coins, there will be a head. 2, 3, 4. Now we see the random variable values are countable. These values start from 0 up to 4. So the random variable values are countable. It is called a discrete. And what is meant by a continuous random variable? I'll give an example. The life of a pan or a tubelight in your home. Suppose we go to a shop, we buy a fan or a light. A warranty is given. Suppose 2 years or 3 years like this. So up to this function is discontinuous. The entire process is possible. That means we buy a fan. For example, we buy a fan in our home. We put a switch, then the fan will continue the process. So whenever we put the switch, the fan function will be continuous. So this function is called a continuous random variable. So this function is possible up to the total lifetime of a fan. So this is the continuous and discrete random variable. First we see some discrete random variable. First of all, what is meant by a random variable? A random variable is a variable. It is possible in some events. This happen, it may be possible or impossible. Now we go to sums of exercise 11.1. It is the first sum of your exercise. Now you see the question. It is a question. Suppose x is the number of times. You denote capital X is given. X is the number of times occurred when 3 fair coins are tossed once simultaneously. So how many coins are tossed is very important. How many coins? 3 coins. X is the number of tails. So this is called the random variable of that sum. Then our question is find the values of the random variable x and the number of points in its inverse image. No problem, inverse image means how many values are possible in random variable. So first is very important, x can take how many values. Where x is the random variable here. So first I write the sample case. When 3 coins are tossed, what is the sample base? When the coins are tossed, how to find the sample base? A general formula is the formula is 2 power n. where n indicates the number of coin. 2 power n is a general formula when the coins are tossed. When the dice are tossed, the general formula is 6 power n. 2 power n, where n is the number of coin. Here how many coins are tossed? 3 coins are tossed. So 2 power 3. The value of 2 power 3 is 8. So the values of the sample phase occurs 8. First one is H. That means all the 3 coins having the phase is 8. Then HHT. First 2 coin is 8 and the third coin will be 10. Then we move this T. So repetition is not allowed. So we move the T. So we write all the values. T, H. So 4 values is possible. Next, suppose TDT. That means all the 3 coins having the phase is 10. Then TTH. Then we move this H. THT. HT. Now you count. There will be 8 evens is possible. 1, 2, 3, 4, 5, 6, 7, 8. So what is the value of n of s? So n of s value is 8. So in probability sum, first we find the sample phase. Sample phase means all the possible outcomes. When 3 coins are tossed one time, so these are the total possible outcomes. So what is the meaning of that one? TTH means first 2 coins there will be a tail and the third coin is 8. Is it possible? And this one is first coin is 8, second, third coin will be 10. So to tell all possible outcomes is nothing but a sample phase. So n of s value is 8. Next, where x denotes here. X denote the number of tails. So it's important. Let x denote the number of tails when 3 coins are tossed. Let x denote the number of tails when 3 coins are tossed. Then this x value is nothing but a random variable. There is a chance of tail will come when 3 coins are tossed. Yes, there is a chance. So this event is called the random variable. Then this x value is called the random variable. Then x is the random variable. Okay, this x is called the random variable, which can takes the value the values of the random variables are very, very important. Then this x random variable which can take the values, I say 0, 1, 2, 3. We must understand how to come 0, 1, 2, 3. We tossed how many coins? 3 coins. We assume x is the number of tail. Suppose when we toss 3 coins at a time, no tail is possible. Okay, this event is possible. So this value is 0. That means there is no tail. 1 means out of 3 coins, any one coin will have the face is a tail. Remaining 2, 8 is understood. So this event is 1. 2 means out of 3 coins, there will be 2 coins is tail and 1 coin is 8. 3 means all the 3 coins having the faces tail. So x can take the random variable. The random variable values are very, very important. So here x can take these 4 values. So what is mean by 0? No tail. 1 means out of 3 coins there will be 1 tail. 2 means 2 tail and 3 means 3 tails. Now we find that random variable values. Next, one more question is also given. What is the number of points in inverse image? So now we write 1 by 1. X of 0. X of 0 means the random variable suppose having the value is 0. That means no tail. So no tail, how many values are possible? Now we see the sample phase. In sample phase, no tail events is. This one contains 1 tail. Tail, all are indicating tail. Without tail, only 1 event is possible. That event is H. So we write here H. is consider only one value. So 3 coins are tossed one time. So HHS is one single event. So HHH, the value is 1. Next, x of 1. We write 1 by 1. X of 0 over. Next, x of 1. X of 1 means one tile will come. One tile will come is understood. The remaining 2, it may be a hit. So what is the total number of one tile possible? Now again we see the sample phase. One tile we need. Here there is no tile. HHH. HHT. Okay, one tile is there. HTH. Here also one tile. THH. One tile. Remaining all are 3 and 2 tiles. So we need only one tile. So the possible events are HHT and HTH, THH. So how many events are there? 1, 2, 3. So that value is 3. Next, x of 2. X of 2 means the random variable x as the value is 2. That means 2 tiles. In 2 tile event, how many values are possible in the sample phase? Now again we see the sample phase. Now we need 2 tiles. No tile. 1 tile, 1 tile, 1 tile. So this all values is impossible. Here, hollow tile. We assume 2 tile only. TTH, okay, 2 tiles. THT, 2 tiles. HTT, 2 tiles. So we will be taking the 2 tile events. The events is start from TTH. THT, HTT. This is also 3. Next, x of 3 is the last one. X of 3 means all are 10. I write just TTT, value is 1. Do you understand? X of 3 means a random variable which contains the value is 3. 3 means all the 3 coin having the face is a 10. All the 3 coin having the face is 10 is only one event TTT. Remaining all, there is no 3T is available. So the random variable values is 0, 1, 2, 3. And the number of points in inverse image value is 1, 3, 3, 1. For convenient, we form a table. In the first table, we write the values of the random variable. First one we write the values of the random variable. And next one, we write the number of points in inverse image. You see the question, there will be 2 questions like that. First, we find the values of the random variable. Okay, we already find. And next, number of points in its inverse image. So number of points in inverse image. Number of points in its inverse image. How many random variables are there? There will be 4 random variables. Start from 0, 1 to 3. So we form a 4 columns 0, 1, 2 and 3. Our last one is a total values of the number of points in inverse images. First we write the values of the random variable. The values of the random variable 0, 1, 2, 3. That's all. And the number of points in its inverse images. The random variable x value is 0. So its inverse images, that is the last one. What is the value? The value is 1. So this value is 1. When x is equal to 1, whose inverse image total value is 3 is nothing but inverse images, so 3. When x value is 2, that is a random variable is 2, the number of points in its inverse images is again 1, 2, 3, so 3. When x value is 3, total value is here 1, so here 1. Next, our total means we add the total number of points in inverse image. 1, 1, 2, 5, 8. So the total value should be is equal to the sample phase. You know very well, the total probability value is always 1. The number of points in inverse image total value should be is equal to the sample phase. What is that value? 8. Now we see the sample phase value. The sample phase value is also 8. Suppose XZ will come the sample phase, our question is, our answer is correct. So now the first one is over. So how to find the random variable? The values of the random variables are very, very important in all the sums. It is countable, is called the discrete. Now we put the sum, the value is discrete because it is countable. When the coin is tossed, when the dice is tossed, all the events is always a random variable is follows in discrete. Some more problem is calculated in continuous also, but the number of coin and tile will be tossed, all events are a discrete random variable. Okay, now we move the second question. You see the question. In a pack of 52 playing cards, 2 cards are drawn at random simultaneously. How many cards are taken is also very important. How many cards? There will be 2 cards are taken simultaneously. If the number of black cards drawn is a random variable, we assume the number of black cards, okay, number of black cards is a random variable, then there will be same 2 questions. Find the values of the random variable and the number of points in its inverse images. So in a 52 cards, you know very well how many black cards are there? There will be 26. Our remaining 26 is a red card. You will be taking any 2 cards simultaneously at random. At random means without seeing the card. Without seeing the card, out of these 52 cards, you will be taking 2 cards. Suppose if it is a black card, what is the total values of the random variable and its inverse images? So first we write the sample phase. So what is the sample phase here? You don't take only 1 card. You will be take any 2 cards. For example, I say in clover I will be take the ace and 2. Is 1 chance. You take anyone. Suppose a person will be taking spade, queen and jack. Is a 2nd way. So to tell all possible ways using combination. In on this standard using the concept of the combination. Okay, permutation and combination. So total number of cards is 52. In 52 we will be take how many cards? There will be 2 cards. So we write first of all the sample base. So directly write the sample base. N of s is equal to 52. Now lower class, when the card is given, N of s value is 52. Because out of 52 we will be taking only 1 card. So 52. But here there will be no 1 card. There will be taking a 2 card. So many ways are possible. I imagine I have 52 cards. You pick one person. I will be taking any 2 cards. Suppose the first person will be taking any 2 cards. Then we say the 2 cards we put in the same box. Then another person will come. We take in another 2 cards. So to tell all possible ways is nothing but here the sample phase is a 52C2. What is the reason to write 52 here? Total number of cards is 52. In 52 we will be taking how many cards? Just 2 cards. So I write 2. 52C2. You know very well how to find a 52C2. 52 into 51 by 1 into 2, okay? 2, so it is 2 times 52, 51 by 1 into 2. In second table there is a chance is a 26. So 26 into 51. So you multiply here 26 into 51. 6 ones are 6, 6 5s are 30. 2 ones are 2, 2 5s are 10. So 6, 2, 3, 1. So 1326 is the value of N of s. 1, 3, 2, 6. In all probability sums, first we important to find the sample base value. Now the total number of inverse image, it should come exactly 1326. Okay, sample base is over. Next, we assume which one is a success here? The number of black cards. Important is not a black card, number of black cards. So let X denote the number of black cards. Now we will be taking the value or the symbol of the random variable is X. So we will be taking this X. Let X denote the number of black cards. When Let X denote the number of black cards. When 2 cards are drawn, how many cards will we take? 2 cards. So when 2 cards are drawn. Let X denote the number of black cards when 2 cards are drawn. Then this X is nothing but a random variable. Then X is a random variable which can take the values. How many values is possible? The values of the random variables are very important. Which can take the values? You identify the save the previous one. In 52 cards, we will be taking any 2 cards. X denote, important, X denote the number of a black card. I say one event. Suppose I will take any 2 cards at random. Both the card is not a black, there is a chance, okay? Both the card is a red. So X value is 0. Because we assume card didn't come. So the value of X is 0. 0 means both the card is red. We tell one more chances. Suppose out of these 2 cards, 1 card is a black and 1 card is a red. So 1 card is a black is a chance. So 1. Another one chance is 2. 3 is not come here because we will be taking totally 2 cards. X denote the number of black cards. So there will be 3 chances are possible. 0 means in all the 2 times black card is not come. 1 means in out of 2 times, 1 time is a black card and 1 time is a red card. 2 means suppose there is also a chance both the card is a black. So X is a random variable which contains the values is 0, 1, 2. You don't memorize this concept, we must understand this concept. The values of X is very important. Suppose we find it correctly, then all the problems are very easy. So X value is 0, 1 and 2. Now the random variable values, we find the first one 0, 1, 2. Next, to find the number of points in inverse images, we go to the same model of the previous one. So to find X of 0, X of 1 and X of 2. First we find X of 0. X of 0 means no black cards. No black card means is understood both the card are red. So the red card will come out of. How many red cards are there? There will be a 26. See 2. So what is the reason we write here 26? We assume no black cards. So no black card means a red card will come out of 26 red card, there will be 2 card will come. So 26 C2. So now we find the value of 26 C2. 26 into 25 by 1 into 2. We cancel here. So 13. In second table is 13 times 13 into 25. So 13 into 25. 3 5 is 15. 5 element of 1 is 7. 125 is 25. 5, 2, 3. Is 325. So X of 0 values is over. That is no black card is over. Next one. X of 1 is important. It's a X of 1 means one is a black card and another one is a red card. So now we write X of 1. 1 black card. It's very important. One black card means the another one it has a red card. So to write all values, 1 black card we assume. But we will take how many cards? 2 cards. So one is a black means the another one it come red. So how to write? 1 is a black card. So we write it is 26C1. How I write 26C1? The number of black card is also 26. We assume how many black card will come? 1. So 26C1 is understood. We don't take 1 card. We will be taking 2 cards. So it again 26C1. You don't confuse. You will be taking a 2 card. We assume 1 card is a black. Is understood the other card will be a red. So out of 26 black card, 1 card will come. Another 26 red card will 1 card is Okay, 26C1 into 26C1. Sir, we assume one is black card. What is the reason to write another one, sir? We will be taking how many cards? 2 cards. We assume only one card is a black, so the other card must be a red. So to tell both. So what is the value of 26C1? Whenever NC1 value is always M. So the value is 26. Here also 26. So 26 into 26. I multiply the value 26 into 26. 6 6 are 36 6. Remainder 3. 15. 2 into 26 is 52. So 6, 7 and 6. So 6, 7, 6. Next one. X of 2. That means 2 black cards. Both the cards are black out of 26 cards. So 26 C2. We already find the value of 26C2. The value of 26C2. We already simplified that value is a 325. So 26C2 simplification is a 325. So here also I write that value is 325. But you don't confuse, sir. Both the values is 26C2. How it is possible, sir? No black card means out of 26 red card there will be a 2 red card will come. Okay, here. And here 2 black card means out of 26 black card 2 black card will come. So here also 325. So to find all the inverse images, next we form a table. Same table. What is the first column will occur? The values of the random variable, and the next one is the number of points in inverse image. So values of the random variable. First column over, and second column number of points in his inverse image. Okay. How many values are the random variable? There will be 3 values. The values are 0, 1, 2. So we form 3 columns: 0, 1 and 2. And the final one is the total number of inverse image. So we write total. Okay. The random variable values are 0, 1 and 2. The random variable values are 0, 1 and 2. We already find the values of the random variable 0, 1 and 2. When x is equal to 0, whose final value is nothing but an inverse image. What is the final value? 325. When x is equal to 1, whose value is nothing but the inverse image. So the value is 676. And next, x value is 2, whose inverse image value is again 325. To add r, that is the total must be equal to the sample phase. So now we add 5, 5, 10 plus 6 is a 16. In 16, 6. Remainder 1, 3, 10, 12. In 12, 2, remainder 1, 4, 10, 13. So 1, 3, 2, 6. Now we check that value is exactly the sample phase. So 1326. Now you see the sample phase value is also 1326. So the total number of the inverse image should be is equal to the sample phase. Then our answer is correct. Now we move to the next question. You see a 6-sided die is marked 2 on one face, 3 on 2 of its faces, and 4 on the remaining faces. We see in a lower class, a die is there will be 6 faces whose marks are 1, 2, 3, 4, 5, 6 like this. But this is a special die. Is one of his faces mark is 2. And 3 on 2 of his faces. The remaining 2 faces is 3. And the remaining 3 faces is marked as a 4. The 3 faces. The die is thrown twice. Twice means. If x denotes the total score in 2 throws, total number of values x denotes. Find the values of the random variable and the number of points in inverse image. So first we write the sample phase. Here the sample phase 36 is not possible because 2 phase comes 3 and 3 phase comes 4. So what is the total phases? In 2 throws means first one it may be 2 comma 2. Okay. First throw 2, second throw is also 2. 2 comma 3, 2 comma 4. So we write in order 2 comma 2, 2 comma 3, 2 comma 4. Next 3 comma 2, 3 comma 3, 3 comma 4. Next 4 comma 2, 4 comma 3, 4 comma 4. So this is the sample base here. So why it is not occurred at 36 here? Because 2 of 3 phases is a 4, 3 phases will come 4 and 2 phases will come 3. So out of these 3, any one 3 will come. So S value is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's a special die. So the sample phase value is 9 only possible. So N of S is equal to 9. So this is a sample phase here. It's not consider all the 6 phases are differ. 3 of phases is 4 and 2 phases is 3. So N of S value is here 9. Now X denote the total score. Total score means we add these two. 2 plus 2, 4. So minimum value is 4. 5, 6, 7, last is 8. So the total score is start from 4 up to 8. So this is our required values. So first step to find the sample base. Next step, X denotes the total score. So we write, let X denote the total score when 2 dice are thrown, alright? Or will I just let X denote the total score? Then this X is a random variable which can take the value the values of X are very, very important. We already tell. X denote the total score. Then the X is a random variable which can take the values. We already tell the what is the minimum number of total score or the maximum number of total score. You see the sample phase. The minimum number of total score. Total means we add this 2. 2 plus 2, 4. So minimum value is 4. 5 is also possible. 6. Again 5. You see 7. Last one is 8. So we start from 4. 5, 6, 7, 8. So the values of the random variables are very, very important. Where X denote the total score. So minimum total is 4 and the maximum total is 8. Then in between all values is possible. So random variable values are finded. Next to find inverse image. So first X of 4. X of 4 means the total is 4. Total is 4. How many values are possible in sample phase? You see in sample phase, total value 2 comma 2, so only 1. You see all the remaining is not 4 will come. So 2 comma 2. So how many event? It's only one event. So 1. X of 5. Next value is 5. X of 5 means the total score is 5. How many values are possible? 2 plus 3 is 5. Is one value is possible. So 2 comma 3. Any other? 3 comma 2. This value is also possible. Any other is the? It's a 6, 7, 6, 7, 8. So just 2. So just 2 values. Next. X of 6. X of 6 means the total value is 6. Now we check the sample base. Total value is 6. 4, 5. This value is possible. 2 comma 6. Next is a 5. This value is possible. 3 comma 3. Another one 4 comma 2. So total value is 3. So that means we add these 2, we get 6. 2 plus 4 6. 6. 4 plus 2 is 6. So 6 over. Next 7. So X of 7. X of 7 means the total will come 7. The total 4, 5, 6, again 5, 6. This one is 7. 3, 4 is 7. Any other is possible? We check. Is 6. Again is 7. How many values are? 2. Last one is x of 8. X of 8 means the total value is 8. This all values is impossible because it is less than 8. But last value 4, 4. 4 plus 4 is 8. So that value is 1, 3, 6, 8, 9. Next we form a table. In first is the first column, is the second column. In first one we write the values of the random variable. Okay, values of random variable. Next one, number of points in inverse image. In inverse image. So how many values of the random variable? We start from 4, 5, 6, 7, 8. 4, 5, 6, 7 and 8. Last one is a total. The first random variable values are 4, 5, 6, 7, 8. Next, the number of points in inverse image. When x is 4, the inverse image value is 1. Is 5, 2, 6, 3, 7, 2 and 8 is 1. Now to add all. 3, 6, 7, 8, 9. So total value is 9. You check that value is exactly the sample phase. The total value is 9. Now we check it is exactly the sample phase. The sample phase is also 9. Okay students, today we see what is meant by a random variable and the random variable, how to find the number of values of the random variable. Now the same model sum lies in example also. We must try in our class note.